Hello, welcome to Patch Math. Today we are talking about linear equations. In this case, this problem is asking us to find the slope and y-intercept of that equation by converting to slope-intercept form. I went ahead and added the graphing option because honestly, if you're going to find a slope and intercept, you might as well graph it. It's like just a few extra seconds. In this case, I really want in your head when you hear convert to slope-intercept form, that really means solve for y. In this case, if we take our equation and we solve for y, we will be doing the opposite operation of how the terms and coefficients are attached equally on both sides of the equal sign. I have a video supporting how we solve equations using opposite PEMDAS or opposite order of operations to guide us. So anytime we're doing the operation as it's given, just real quickly, if we're doing the operation as it's given, that's PEMDAS. Parentheses, exponent, multiplication, division are created equally. Addition and subtraction are created equally. However, in this case, we are solving by using the opposite operation. That tells us we need to use opposite PEMDAS. Now, because addition and subtraction are created equally, they come first, then multiplication and division, then exponents, then parentheses. In this case, we have addition, and then we have multiplication. Excuse me. We have addition and multiplication to undo. So using opposite PEMDAS, I am going to do the opposite operation equally on both sides of the equal sign. These cancel. And we are left with negative 2y equals negative 6x plus 2. Now, because this is asking us to convert to slope-intercept form specifically, slope-intercept form says that y is equal to mx plus b. And so we want to follow that form whenever we are reorganizing it when we solve. Now, the only operation that is left is getting rid of that negative 2 attached to the y. That negative 2 is attached by multiplication. When you don't see a sign between the number and the variable, that is multiplication. In this case, everything has to be divided by negative 2. That cancels, and that was the purpose. Then we are left with y equals. In this case, there's invisible parentheses around that numerator, meaning we have to distribute that division of negative 2. In this case, that just means taking negative 6x and dividing it by negative 2, and that gives you 3, because negative 6 divided by negative 2, negative divided by a negative is a positive, and the 6 divided by a 2 is a 3. We have to do that same thing here, but in this case, we have 2 divided by negative 2, positive divided by a negative is a negative, and 2 divided by 2 is 1. We now have this in slope-intercept form. Y equals mx plus b. That allows us to real quickly see our m. All right. M equals 3 here. And our b. In this case, b is equal to negative 1. We do take the sign that is in front of the number with it. Now we graph y-intercepts. This is specifically y-intercept, super important. We graph the y-intercept on the y-axis. In other words, x is 0 in our ordered pair, and y is negative 1. So that's where I start. I'm using normal units, so counting by ones here. And because that is negative 1, here's our origin. And there we go. That is our y-intercept, 0, negative 1. From there, we can use our slope to generate the rest. But if you'll notice, slope is defined as rise over run. In this case, you'll notice we just have rise. There is an invisible run. In mathematics, we have these things called invisible ones, and we use them for certain situations. In this case, we have an invisible 1 under that 3 right there, because 3 divided by 1 is still 3. So our rise is positive 3. That means up 3. Positive 3, up 3. And then our run is positive 1, so right 1. Positive directions are right and up. Our negative directions are down and left. Sometimes it helps to write those labels there. So we have positive 3 over 1, 1, 2, 3, 1. Some people will show the staircase, and you'll notice it's a rise 3, run 1, rise 3, run 1. And it does only take 3 points to confirm your line. Technically, it only takes 2. The third is more of a confirmation to make sure the other 2 are correct. If for some reason at this point you didn't have a line, it's not exactly on it. There we go. If at some point you didn't have a line, like it had a little wave in it, just go back and check and make sure you counted your rise over run correctly. And there you have it. Here is a graph of that line by identifying the slope and the y-intercept and generating the rest from there. All right. Thank you so much for your time.